Hi and welcome to this video where we're going to look at predicting whether or not a precipitate will form. This is a really common sort of a question in NCEA, and so it's very important to consider. This uses the reaction quotient, or Q, which you will have come across at NCEA level 2 when you're talking about equilibrium. So just to recap, Q, the reaction quotient, is calculated exactly the same way as K. So using exactly the same equation as K, but the concentrations may or may not be at equilibrium. Okay, so this is basically what you do when you've got some concentrations and you want to find out if they're at equilibrium. So what you do is you do the calculation the same way, then you compare Q and K, and that will tell you whether or not it's at equilibrium, and if it is or not, what needs to happen. So if Q is the same as K, then the reaction is at equilibrium. If Q is greater than K, then you've got more products than you would expect to find at equilibrium, so the reverse reaction is going to be favoured, the equilibrium is going to move to the left. If Q is less than K, then the concentration of the reactants is greater than it should be at equilibrium, so the equilibrium is going to move to the right and is going to be product favoured. The forward reaction is going to be favoured, basically. Now, what does this mean in terms of solubility? Well, very simply, we've got at equilibrium, what we're talking about is a saturated solution. So if Q is equal to Ks, then the solution is saturated. Okay, well, that's pretty obvious, I think. If Q is greater than Ks, then a precipitate is going to form because the concentration of the products is greater than at equilibrium, it's supersaturated, so you're going to get precipitation happening. And if Q is less than Ks, then it's not yet saturated, so you can dissolve some more of the solid to make, anyway. In some textbooks, you may find Q called the ionic product, which is only relevant in solubility equilibria. Just like Ks is the solubility product, Q will be the ionic product. It's still basically the same thing, it's just different ways of referring to it. Okay, so when you're being asked a question about will a precipitate occur, what you actually have to think about is what is Q, and is it greater than Ks or not? So here's an example of an NCEA question. I believe this one was from about 2017. These pop up with reasonable regularity. This question was asking you to show by calculation whether a precipitate of silver carbonate will form when 20 ml of 0.105 mol per litre silver nitrate solution is added to 35 ml of a 0.221 mol per litre solution of sodium carbonate. And you're given Ks for silver carbonate. So the first thing you have to think about, okay, there's two things. First one is you are mixing two liquids together, so you're going to be diluting the two solutions that you've got. So the concentrations of the ions are what they are. The second thing is you've got silver nitrate and sodium carbonate, so you've got to look at the ratios of when those two things dissolve. Now, hopefully you can just do this by eyeball and go, okay, well, silver nitrate's going to break up. It's a 1-to-1 ratio. You're going to get 1 silver, 1 nitrate. So the concentration of silver nitrate is going to be the same thing as the concentration of silver or the concentration of nitrate. Not a problem there. Sodium carbonate, for every sodium carbonate that dissolves, I'm going to get 2 sodiums and 1 carbonate. Since I'm not worried about the sodiums and only the carbonate, then that's fine too. So that's the first thing you need to look at. The second thing you need to look at is, like I say, the dilution factor. Okay, so the concentration of silver ions, well, we've got 0.105 mol per litre silver nitrate. We've got 20 mils of that, and the total volume of the combined solution is going to be 55 mils because you've got 20 mils of one and 35 of the other. So you're going to take silver nitrate times by the volume of silver nitrate divided by the total volume. So it's going to give us a concentration of silver ions, 0.0382 mol per litre. We're going to take our sodium carbonate to get the carbonate ions. Again, we've got the concentration of sodium carbonate, times by the volume of sodium carbonate, divide by the total volume. Gives me a carbonate concentration of 0.141 mole per litre. Now hopefully you can look at this very simply and go, with these two concentrations times together, even if I'm squaring one or the other, they're going to come in way bigger than Ks, but we still need to finish off the calculation. So Q is equal to the concentration of silver ions squared times by the concentration of carbonate ions. Let's put those numbers into the equation. There we go, 0.0382 squared times 0.141 is going to give me an answer, 2.06 times 10 to the minus 4. That's the calculation. We have to answer the question. This is always really important. So, since Q is greater than Ks, a precipitate will form. It's always important to put that final statement in. If you don't, you won't get full marks for the question because you haven't actually answered the question. Okay, so that's how you can figure out whether a precipitate will form or not. Come back for my next videos where we're going to look at some other things that can happen with equilibria.